Good day, grade 11s. In this lesson, we are going to look at Unit 5 of the module, and the heading says experimental yield. Now, first of all, the word yield refers to the amount of product that is formed. That is the yield that they are referring to here. And why do they say percentage yield? If we think of percentage again, we talked about it in a previous lesson as well. If you want to calculate your percentage, it was theoretically what you're supposed to get and what you actually got, and you took the two, made a calculation, and you got your percentage that you got for the test. Now here with the experimental yield, it is something similar. With a percentage yield, a chemical reaction took place. We calculated a certain amount of product will form, only a percentage of it forms. So therefore, we're going to calculate the percentage yield. And this difference in the theoretical yield and the actual yield can be contributed to things like impurities. Now, I have a quick example that I want to show you. You all are very familiar with how to make hot dogs, right? What do you need? You need to have hot dog Viennas, and you need to have a bun. And in a normal, typical world, you put one Vienna into one bun, right? So if you look at what we have here, we have 1, 2, 3, 4, 5 hot dog Viennas, and we've got 1, 2, 3, 4 buns. So theoretically, how many hot dogs can we produce? So 1 to 1 makes a total of 4 hot dogs then, right? So that's my theoretical yield, and I'm left with one Vienna, and that Vienna is then called my excess reagent, the leftover Vienna, right? So that is now what we think of what's going to happen when we start, and we're going to theoretically make 4 hot dog buns. But the moment that we started, one of our buns was not suitable for use. It could have been old, it could have been wrongly cut or something like that, and suddenly we're not producing 4 hot dog buns, but we only produce 3. So what was our percentage yield? 3 divided by 4 times 100 is only 75% of what we were supposed to get. So we have a way that we can calculate my percentage yield. I calculate it by making use of a formula that says percentage yield is equal to the actual yield divided by the theoretical yield multiplied by 100. Right, let's quickly do the example that we have with this. For the first one, when we have 12.8 grams of copper, it is allowed to burn in oxygen to form copper 2 oxide. Write the balanced chemical equation for this reaction. So my formula, copper plus oxygen. Oxygen diatomic, so therefore it must be O2. Reacts to form. And what does it form? It says copper oxide, copper 2 oxide. So the formula CuO. Right. Is it balanced? No. There's 2 oxygens, there's 1. So I need to place a 2 in front of the copper and a 2 in front of oxide and a 2 in front of the copper. If you know the phases, you can fill them in. The copper will be solid, oxygen will be a gas, and copper oxide is a black powder, so that's also a solid that's going to form. That part is not important if it's not asked. The question continues and say that we have 12.8 grams of copper, and it is burned in oxygen, and 15.2 grams is produced. Right, so now they say go and determine the percentage yield. And you'll see that our next page of the notes are empty blank page, because that's where we have to go and do these calculations now. Right, so I'm going to put that on that we can keep on having a look at that. So what's my steps of any calculation of anything? I have to go and work towards my percentage yield is the actual yield divided by the theoretical yield. Now what do I have here? I've got masses. I've got the actual mass that formed, so I need to go and calculate what is the theoretical yield that formed, so that I can calculate what was the percentage yield in this case. Right, so step 1, we need a balanced equations which we already have from our previous question. Step 2, we have to go and convert what we have given. Now, it's very important to now not get confused in this case. Remember now, this 15,2 is already my actual mass. So this is my actual that we are going to use with. What am I going to do with this 12,8 gram? I'm going to calculate theoretically how much was supposed to form from 12,8 grams of copper. Right. So step 1, have a balanced equation. Step 2, convert what is given into number of moles. Just be careful that I stay on the allocated space here. So number of moles is mass over molar mass, and we're talking about the copper. The mass of the copper, 12,8. The molar mass of copper I found on the information pamphlet as 63,5, and that works out to be 0,2 mole. Right. Once I have that, I use my mole ratio, and according to my balanced equation, 2 moles of copper forms 2 moles of copper oxide. So the ratio that they are in the number of moles of copper to the number of moles of copper oxide is 1 to 1. So therefore, the number of moles of copper oxide that's going to form is 0,2 mole. With that, I'm now going to be able to calculate a mass, and this is going to be my theoretical mass that I've calculated. My theoretical mass is going to be the number of moles times the molar mass of the copper oxide, right? So 0,2 times, and my copper oxide is 63,5 plus 16. Now using your calculator, and please always go and check that this was done correctly, is 79,5 times the 0,2, which gives me 15,9 gram. Right, now what do we see? The actual mass, 15,2. The theoretical mass, 15,9. So from 12,8, there was supposed to be forming 15,9. Now there's only 15,2 that formed. Right, so why was not enough formed? Because the copper that was started with was not completely pure. Right. Our question was calculate the percentage yield. So I write down the formula, percentage yield is equal to, it's a mass over a mass, and it is actual over theory, multiply 100. So that gives me 15,2 over 15,9 times 100. And the percentage purity in this case was then 95,60%. Right. And there we know how pure this sample of copper was. Right. So in your textbook, they refer you to activity 1.9. If we just quickly go and have a look at the textbook, there's another example that is worked out for you. There's an experiment, and as I said before, go and read through experiments because it gives you a little bit more insight to it. And in the activity, I'm also going to say try all of them, but make sure that you can do the ones that was listed here. We will put all the answers onto the onto the Google Drive. Right.